Hello viewer, welcome to the summary of effect of terminations on the hydrogen evolution reaction mechanism on titanium carbide MXene. The surface terminations of MXenes, such as fluorine, oxygen, hydroxyl, and hydrogen, are seen as influential factors in catalysis. However, the research in this area is still limited. In previous studies, many investigations focused only on fully terminated surface or mixture of O and OH terminations. So our research focuses on different surface terminations and the realistic conditions. Next, we consider the different ratio of surface groups, including the fully termination, binary, and ternary configurations, as well as different cell size. These considerations resulted in approximately dozens of possible scenarios. Subsequently, geometric structures for 2x2 and 3x3 cell were conducted. Next, we performed calculations to determine the most stable site. Here we take fluorine 1/3, hydroxyl 1/3, and oxygen 1/3 as an example. And here, 4 types of absorption sites: top, bridge, hollow titanium, and hollow carbon were considered. And in this case, the hollow titanium site was found to be the most stable. And subsequently, we conducted the calculations of absorption-free energy, taking into account the pH and the potential. And based on these calculations, we derived the stoichiometric coefficients for hydrogen ions, electrons, and fluorine ions, and then plotted the corresponding Pourbaix diagram. And firstly, for fully terminated surface, we consider 2 cases. One is fluorine-free, and the second one is fluorine-containing. And furthermore, we also consider the binary and ternary surface terminations. Ultimately, we selected 5 cases near the HER equilibrium line and within the low potential and low pH. Furthermore, the possible mechanism of HER were also considered, primarily including the Volmer-Tafel and the Volmer-Heyrovsky. And this is the energy profile associated with the Volmer-Heyrovsky mechanism, and it can be observed that comparing with the fully terminations, the mixed terminations significantly reduce the reaction energy. Additionally, we also took into account the involvement of the hydrogen atoms on the surface terminations and resulting in different types of reaction pathways. For example, the OHTR pathway indicates that the hydrogen reduction occurs on the hydroxyl groups, and the OTR pathway indicates that the hydrogen reduction occurs on the oxygen groups, and the TRTR pathway suggests that the hydrogen atoms on the surface tend to interact with each other to form hydrogen molecule before the hydrogen reduction. And these results indicate, in certain cases, the hydrogen on the surface terminations is favorable for HER and reduce the energy required. Furthermore, we also calculated the energy profile associated with the Volmer-Tafel mechanism. And finally, based on the calculated delta G as a descriptor, we summarize our study, and the results indicate that these 3 cases exhibit the best performance in the HER reaction. And interestingly, contrary to previous research conclusions, the fluorine are not detrimental but rather beneficial to the reaction. And lastly, thank you to all the associations and organizations involved in this research, and thank you all for the end. Please follow our channel updates. Hope to see you soon. Bye.